Lotus Elise here, just going ahead and being sick. I'm going to go ahead and take the day, and of course I'm going to go ahead and leave work for you guys, but I just wanted to go over these last bit of notes that I wasn't able to get through yesterday. So right here, we're looking at this picture. Of course, everyone knows that this part right here holds true, that this segment is bisected by this little segment right here. So that bisects that one. So uy is equal to uv. Of course, everyone knows that now. So we're going to go ahead and use this one. Oh, no, actually, that's wrong. YV. I apologize on that one. So now we just set that up. So 4x minus 3 is equal to x. Subtract x from both sides. So that leaves us with 3x minus 3 equal to 0. Now we add 3 to both sides. Then we have 3x equal to 3. Divide both sides by 3, so x is equal to 1. And then we just say, alright, well, we have uy here. We can either use this one, but I'm going to use this one. It's easier. So yv is equal to 1, so that means that uy is also going to be equal to 1. Because right here, yv equal to x, which is just 1. And the entire distance is going to be 2. So we have 1 for this one, and then 2. Okay, then we go on to the next solution. Now in this one, we're told uv, which is the entire segment, and then we're given this as the little bit of segment from uy. So that's x minus 1, and then this is x plus 6. One thing we do not want to do is set x plus 6 equal to x minus 1. That's going to be incorrect. So right here, we know that this segment and this segment are congruent. So this is x minus 1 here. So we're going to be using segment addition postulate. So uy plus yv is equal to uv, which is the entire segment. So x minus 1 plus x minus 1 is equal to x plus 6. And then we solve. So now we have 2x minus 2 equal to x plus 6. Add 2 to both sides. 2x is equal to x plus 8. Subtract x from both sides. And this is going to be x equal to 8. Now, when we go ahead and substitute uv, we're going to want the uv, or yv, sorry. This is y to v equal to x minus 1. So 8 minus 1, that's equal to 7. 7 units. This one's a little bit more difficult. It's actually a systems of equation. And let me go ahead and clean this up just a little bit. Do a little bit of magic. Well, it's not really. Just giving us some space to work with. I'm not going to work on that particular example down there. It's just the same. Now, this is a typo, so we need to go ahead and remove that. Just remember that. And on this example, we're going to be doing a system equation because we have x and we have y. And so we're told what AC is equal to. And we also have AB and ABC. So we're going to be using segment addition postulate along with the fact that we have bisectors. So we know that AB is equal to BC. But we also know AB plus BC is equal to AC. So we're going to be using those two in conjunction to go ahead and solve for x and y before we find out what BC is going to be. So we're going to be working that. So I'm going to do the first part. Negative 4x plus 6 plus 2y minus 2 equal to 8x plus y. What a mouthful. Okay, so now we're going to solve for y and x. Actually, we're going to solve for y because that's going to help us do this problem a little bit easier. So add like terms. So we have this one and this one. So plus 4. I'm going to bring this down. Now let's see. It's going to be plus 2y and then negative 4x still. Now I'm going to move the 4x to the other side. So adding 4x to both sides. So this will cancel out. So we have left with 2y plus 4 equal to, let's see, 12x plus y. Yeah. I'm going to subtract y from both sides. So I have y plus 4 equal to 12x. That's it for that one. Now I'm going to subtract 4 from both sides. So y is equal to 12x minus 4. I'm going to pause on that one because there's nothing else to be done with this. So now I'm going to be doing this with my a, b, and bc. I'm going to do sort of the same thing. So negative 4x plus 6 is equal to 2y minus 2. Going to add 2 to both sides. I'm going to get my y by itself just so to let you know. This one cancels. So negative 4x plus 8 is equal to 2y. Now divide everything by 2. Makes everything a little bit simpler. So this ends up being, let's see, negative 2x plus 4 equal to y. Now, since they're both equal to y, I can go ahead and substitute 2x plus 4 for the y over here, so on this side. So now this is going to be 2x plus 4 equal to 12x minus 4. Now we just need to solve for x. This is going to be an ugly problem. So let's see, going to add 4 to both sides. So this is 8 equal to 12x. And I'm also going to subtract 12 from both sides. Actually, let's go ahead and just do that. I did it all together because sometimes you can do that, but I wouldn't recommend it. Do it one step at a time. Then divide both sides by 10. So that leaves us with, let me see, 2, they both have a 2 common, so that's going to be 4/5 equal to x. Talk about ugly. Oh well. Now we need to solve for y. So we can either use this one or this one. I'm going to use this equation over here. Use green, not purple. So negative 2 times 4/5 plus 4 equal to y. Now we're left with negative 8 over 5 plus 4. That's really ugly. Like denominators, so 5 underneath the 4, but that's going to have to be changed to 20. And then we're going to go ahead and subtract 8 from 20, so that's going to be 12 over 5 equal to our y. That is heavily ugly. Now we need to find BC, which is 2y minus 2. And that's going to be equal to whatever our y is, or our BC. So we have 2 times 12 over 5 minus 2. So let's see, that's going to be 24 over 5 minus, so we're going to get like denominators, so 5 underneath right here. That's going to be 10. And that gives us 14/5 equal to BC. Horrible, horrible number. Couldn't they have gotten this a little bit better? Oh well. Thank you for listening. Talk to you guys later.